Hello, hello, hello. Welcome to, whoa, not writing, not writing. I am Mr. Folly, and welcome to kinetics, the next unit. Here we go. So, the thing that I think about the macro scale for kinetics, because all of this is what's happening on a smaller scale, is what does it take to hit a home run in baseball or softball? Okay, to do that, you've got to hit the ball, right? A lot of times people try and hit a ball and they swing and miss. The other thing is you have to hit it with the right orientation, right? If you're hitting ground balls every time, it doesn't matter. You'll never hit a home run. And the other one's with enough energy. So if you're hitting it at the right angle, but you just don't have the oomph to get it out of there, you're not going to hit home runs. Okay? So this is the same idea of what we're looking at here. So we've got collision theory. In order for a chemical reaction to take place, particles must collide, swing and hit. With enough energy, lift those weights, my friends, and the correct orientation. It's a little bit deeper meaning than angle, but it's like that. So correct orientation is what we want to work on. Okay, so to give you an idea about chemical reactions, most reactions don't work. I bet Dr. Tyrell would have 5 people high jump 5 feet today, and I don't lose. So I'm going to cheat. Okay, so just so you know, I'm going to work the system as best I can. So how do I increase or speed up the rate of successful collision? So a successful collision in this case would be somebody going and going over this and successfully making it. Probably not land on their head, to get the idea. So how do I increase my chances here? I can increase my collisions. So increase my attempts. Go find crowds of people to ask to jump. Go to football games. Go to concerts. Just the number of collisions, people, will get me a higher frequency of successful collisions, right? So if I can find just a bunch of people, I'll be able to find 5 people that can high jump 5 feet. High jumping high 5 feet is really hard, so you got to find a bunch of people, and maybe you'll get some. Increase my energy. If I just say, "Hey, high jump 5 feet," most people would say no. I'm not even going to try. But to get them to try, give cash prizes. You've all seen the TikTok where the guy gives you $20 for every pull-up you do or whatever. You try at least one if you give you $100 for it, right? Give energy drinks. Have people warm up. So more energy would give you a higher frequency of successful collisions. So we can increase that energy somehow. A catalyst. I could put a trampoline at the base so that people require less energy. Or I could put the 5 foot, so if my high jump is 5 feet tall, and then I put it in a hole, right? Yeah, so it's set at 5 feet, but it's in a hole, so more people can do it. So put the 5 foot height in a hole, so it's easier. If you reduce the energy required, you get a higher frequency of successful collisions. Can you tell we're looking for a higher frequency of successful collisions? So this frequency of successful collisions is where we're focusing on rate, not number, rate. Okay. So if I ask you how do I speed up reactions, I can increase the concentration. This would increase the particles per volume. More collisions in the same time, I have a higher frequency of successful collisions. I can decrease the volume of gases. This only works for gases, right? So then you'll have more collisions in the same time. Increase the temperature, double whammy. So this is a big deal. If I increase the temperature 10 degrees Celsius, I often double the rate. So imagine if you turned up the temperature 10 degrees at your house, you got your homework done twice as fast. Look out, heating bills. Here we go, right? So increase the temperature, you get a higher frequency of successful collisions because remember, particles are moving faster. So if they hit faster, there's going to be more with enough energy. Plus, if they're moving faster, not only they have more energy, but there's going to be just more collisions. So more collisions will give you a higher frequency of successful collision. A catalyst will speed up the rate. This lowers the energy needed to react, so you have a higher frequency of successful collisions because it's easy to be successful, right? So if I want a greater frequency of people getting A's, and you maybe have heard this before, instead of people who get 20% on a test, if you want people to get better grades or on a higher frequency of passing, if somebody gets 20% on a test, what do? You just automatically make it 50%, and that increases the rate of passing, right? You can increase the surface area. So more collisions will occur, so you have a higher frequency of successful collisions. Now, this is one you're probably not too familiar with, surface area. So if I wanted to have a reaction go faster, you'll do this a little bit tomorrow. You're going to have a sugar cube. Now, if I have a cube of something that's going to react, what if I cut it in half? So right now, if I have a cube has 6 sides to react. But if I cut it in half, do you see I've exposed the top side there and a new bottom side there? I now have 8 sides to react. So now I have a greater surface area so that I have more places that can react at once. So what doesn't speed up a reaction? These are my evil tricks. Adding more solid or a liquid. Solids and liquids don't speed up reactions. They don't do it. You need more collisions per time. Now, adding more solids or liquids will end up with more, but it won't go faster. It will not go faster. So if you're trying to put money in a vending machine and you're trying to put it in as fast as you can, it doesn't go any faster or slow if you have $10 or $5. You're still putting quarter, 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 quarter. It doesn't matter if you have $10 or $5. It's still the same rate. Okay. If your job was to drown puppies, what a terrible job. If you do it in a 20-foot pool or a 30-foot pool, it doesn't matter. More liquid doesn't make it any faster. Okay. That's secretly, you know, how those jobs for those lifeguard training things? That's how they train you. They make you drown puppies. I'm joking. My dog's at the foot of the bed. I hope she's not really listening to me. Changing the volume or pressure doesn't affect rate unless it's a gas. This doesn't change collisions per time unless it's a gas. All right, so now I got to be able to handle rates. Okay, rate. So I'm going to have tables. Here's time. So 50, 100, 150, 200. Notice how, whoops, this guy's going down. This guy's going up, right? So this one's increasing. And this one here is increasing too. Right. So rate is change in concentration over change in time. Okay, so it's basically the slope of a line. What is the rate for the first 100 seconds for NO? So change in concentration, which is final, minus initial. That's always what changes. First 100 seconds for NO. Bum, 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 bum. NO. My final 0.0035 minus 0 over 100. Oh no, did I not bring a calculator? Whoops. I should be able to divide by 100 in my head though. So that's going to be 0.000035. This is, it tells you up here, moles per liter, molar per second. Okay. What is it for O2? Okay, so for O2, I'm going from 0 to 0.0018. So 0.0018 minus 0 over 100 equals 0.000018 molar per second. Okay, so it's not the same. Notice this one is about, this guy right here is about double. Okay, that's because it has a coefficient of 2. So it has double the coefficient. All right, oops, let's let that sit. All right, does the rate change over time? So is the rate the same at the beginning, the middle, and the end? So what I'm going to do is I'm going to look at just NO. So NO is 1, 2, 3. So it's 4 zeros, 0.000035 molar per second in NO. So I'm going to check the last 100 seconds. So from 300 to 400, it went from, remember, it's final minus initial, 0069 minus 0062 over 100. So that's 0.0007 divided by 100. So that's 0.000007 mole per second. No. Notice it's not the same. So Sometimes you're generous with your rounding, but man, that's not even close, right? Okay. That's it. We're done. Two toodles.